My name is Anthony Nathaniel and welcome back to Global Education Zone. And today in our further mathematics class, we'll be treating the topic differentiation in sufficient detail. Now, I will start from differentiation from the average scratch, but not from the total scratch, because I've started from the total scratch in a previous video in this channel, and that is in mathematics, the mathematics classes in this channel, and you can check out that. So if you have no knowledge on differentiation, so but before you take this video, always just try to see if you can check out that video. So but basically I will still start from the scratch, but not the total scratch. Now in the video, in the former video on differentiation in mathematics class, I explained the fact that the derivative of a curve is related to the change of the gradient from one point to another. That is the gradient function is related to the change from one point to another. So the coordinates change, and it's that change that is measured in differentiation. And once that change is measured and it can be expressed as an equation, it is called a gradient function. And once that gradient function can be limited to a very specific and tiny amount of x, is called a derivative, and that derivative has an equation also known as the differential coefficient or differential equation. Now today we'll be dealing with the properties of limits. I talked about limits earlier, right? Now in limits, in the previous video I explained that limits has to do with very small changes. And limit, the properties of limit: number one, the limit of a constant is the constant. Now if we have a constant, limit of k as change in x approaches 0 is k. So the limit of that constant is constant. And mind you, we are using chain in x because chain in x will be the standard lettering for this video. So the limit of the constant is constant. Then the limit of a sum of function is the sum of their limit. So if the limit of when chain approaches the limit of a sum of function, when we have limit of function of x and g of x. So this is just like a mapping. I've treated that in the previous video in this channel. Now the limit of a sum of functions is also the sum of their limits. So this will be equal to the limit of chain in x approaches 0 function of x plus the limit chain in x approaches 0 of g of x. Now another last one and very important one I'll be going over, which I will not be going over all because most of them are just similar to this one, because most of the time the limit of a sum of function is the sum of their limits, the limit of a difference of function is the difference of their limits, the limit of a product of function is the product of their limits, and the limit of a quotient of functions is the quotient of their limits. So and that basically is just a repetition of how limits separate, just like how sorts separate. And I've talked about sort in this previous video in this channel. You can check that out. Now one last and very important one we'll talk about is the fact that in limits, we'll talk about the fact that when we have okay, I've treated that. So let's move on to the next part. So now we'll be looking for limits of examples, functions. Okay, let me add this one, that the limit when change in x approaches 0, the limit of 1 over x is 0. So and this is one that's not particularly common with students. So you can just write that down somewhere in your notes, at the back of your head or back of your notes. So basically that will help you to calculate some questions. So let me give an example here. Let's say we have to calculate, we have to find the limit of something like if we have a function of x and we have to find the limit of that function. Let me look for a specific question. We have to find the limit of 3x squared, 3x cubed. Let me start from x squared, limit of example. Find the limit of, as x approaches 5, find the limit as x approaches 5 of x squared minus 25 over x minus 5. Now this is a peculiar question, but note that in limits, the first thing you are supposed to do is not just to substitute 5. So now how limit goes on is that you substitute the limiting value of x, and that limiting value is the value that x will approach. That limiting value is basically the difference between like the closest value close to the final value of x. Now if I am going somewhere, when I get very close to my destination, I will tell you I'm at my destination, right? So that's how limiting value works. So when x is very close to that value, it's called the limiting value. It is not exactly the final destination of the point, but it is very very extremely close to the point. That is it's an appropriate approximation for it. Now when x approaches 5, when we have 4.9999999 going on, that is when it approaches 5. That's also satisfies the equation. So I just explained how limits and how approaching values works. So now let's factorize the top. So let's say the limit of x approaches 5 of x squared minus 25. That's difference of two squares. That's x plus 24, x plus 5 and x minus 5 all over x minus 5. So if you notice, x minus 5 cancels x minus 5 up and down. So we're left with what? The limit of x approaches 5, x plus 5. Now if you notice, this is a limit of a sum. So I explained earlier that in this question I said the limit of a sum is the sum of their limits. So that means the limit of x approaches 5 of x plus 5 will be the limit of x plus the limit of 5. So the limit when x approaches 5 will be, you just simply substitute anywhere you see x, put 5. That will be 5 plus, and then the limit of 5 is 5 itself, because the limit of a constant is the constant. That means 5 plus 5 becomes 10. So that's our answer. So the limit of this question, the answer is 10. That's the typical question you'll be asked to answer under limits. So but just know that basically the first thing you do is factorize, then after that you substitute the limiting value. That is the value that x will approach. Now next, moving on, let's move on to the idea of differentiation from first principle. But before that, let me explain the fact that differentiation is related to gradients of a curve. So I've explained that in a related video, but I will explain it again. Now basically, when you have a curve, the gradient of that curve is given by m is equals to y 2 minus y1 by x2 minus x1. Now you should know that this y is a function of x because it is dependent on the value of x. That means you can say m is what? Function of x2 minus function of x1 over x2 minus x1. But when x moves from 1 to 2, it expresses a change, right? So and that change is called change in x. So that means the function of x2 becomes x1 plus change in x minus function of x1 all over then x2 minus x1, that's still change in x. So now this is also known as the gradient function, and it's represented by f prime of x. So anytime in your question, both in WAEC, JAMB or NECO or whatever exam you write, anytime you see a symbol f prime of x, it is called the differential coefficient or the derivative. Or you can also call it that that's it's also known as the gradient function of the curve, and it can also be known as the derivative of y with respect to x. So that's y with respect to x. It can be anything, so it depends on what is above. Now this function of x is called y, also known as y. So that means y is above and then x is below, right? That's the derivative of y, the numerator, with respect to the denominator. So if you are given change in b over change in c, so this can easily call this the derivative of b with respect to c. So basically it's the derivative of the numerator with respect to the denominator. So moving on, I've in a previous video I proved the fact that that the derivative of x power n is n x power n minus 1. I've proved this in the mathematics video. You can check that out for more solid background in differentiation. But moving on, let's move on to differentiation from first principle. So basically, differentiation from first principle is intimately tied to this. Let me give an example. Imagine we have a question like y is equals to x squared. Imagine we have y is equals to x squared plus 2. Now, and we have to find the derivative of this function, because this is a function. A function is basically a representation of, is a mapping of numbers, if you see it in that way. So a function has a dependent and independent value. So now this function, we have to find the derivative, that is the ratio of the change of the dependent value with respect to the independent value. That's the dependent value is y and the independent value is x. The dependent value is y because y is a function of x. So now let's move on. Now you take in account the changes, the little changes in x. That means you now say y plus change in y is equals to x plus change in x. Then put it square plus 2. Now this y, it is the first position of the state of the function, and then this y plus change in y is the last or final position of the function, because that's the position it attains after it has undergone the change, and differentiation is all about change. Now moving on, this second equation this second equation, let's solve it the further mathematical way. So that will be y plus change in y is equal to, opening this bracket we have x plus, now there's a formula for opening bracket, and that's x plus x, that's x squared plus 2x change in x plus x plus change in x squared plus 2. Now if we cancel out similar terms, if we subtract equation 1 from equation 2, y will cancel y here, right? Then we have x squared cancelling x squared here. Then we have 2 cancelling 2 here. If we subtract equation 1 from equation 2, then we have change in y left. Change in y is equals to 2x change in x plus change in x squared. Now dividing both sides by changing x. So dividing all terms by changing x, divide through by changing x. So changing y by changing x becomes what? Changing x cancels change, that's 2x plus change in x. Because changing x squared divided by changing x, that's changing x. Now when we find the limit of this gradient function, limit at which change in x approaches 0, that's the limiting value, will be equals to, then we'll substitute 0 for change in x, so 2x plus 0. So that will basically become 2x. So in simple terms, the derivative of the dependent function with respect to the independent function of y is equal to x squared plus 2 is 2x. So, and that is also known as the derivative or the differential coefficient. So I hope you understand how to differentiate from first principles. Now next we'll move to other parts, and note that the derivative of the constant is 0. So before that, let's move on to other parts of the of this course. So I stated earlier that I've proved the fact that change the derivative of x raised power n is nx raised power n minus 1, right? So that's on first principles, and no matter what question you are given, the only thing you need to do is that you make a first equation of x, and then you make the second equation of the second state of the or the final state. So the first state will be y is equal to x plus x squared plus 2. That's the initial state. Then the final state will be y plus change in y is equal to x plus change in x squared plus 2. So that is it. You will not subtract the equations. So what you get as final answer, you will not divide by x by changing x. So you get the gradient function, and then you convert your gradient function to a standard derivative equation by finding the limit. So, and that limit will make every change in x term 0. Now let's go to the derivative of the sum. So, not wanting to waste too much time on proving of there's a proof for it, but I won't waste too much time on that. The derivative of a sum, if we have the y over dx, if we have y is equal to u plus v. Now this y is a function, and it's function of a sum. Now the derivative of this is equal to dy over dx is equal to dy over du plus that's is equal to du dx plus dv dx. So this equation here is a derivative of a sum. So, and this also applies for the derivative of a difference. So, and you just simply change the sign between them with minus. So, and then that's the formula. Then next we have the derivative of a product. So imagine we have y is equals to uv. So our derivative becomes dy over dx is equal to u dv dx plus v du dx. So that is the formula for derivative of the product. Then lastly, we'll talk about the derivative. Let's talk about chain rule. So the formula for chain rule is if y is equals to u, assuming u is a function of x and y is equals to is a function of u. That means the y, let's say y is equals to u of x. Let me see. That chain rule is a little bit it's also known as function of a function. Yes, and if we have an equation where y is equals to the function of u and u is a function of x, so if y is function of u and u is the function of x, let's say g of x, then we can simply say that dy du is du, that's, you can say dy dx is equal to dy du times du dx. That's how chain rule works. Next, lastly, we also talk about quotient rule. And quotient rule always occurs when we have a difference. When we have a difference. So let me list the quotient rule. So the quotient rule is simply when y is the quotient of two numbers u over v, the derivative is simply v du dx minus u dv dx over v squared. So these are simply the formulas you use over your study of differentiation, and you can write them down in your notes if you don't have a formula, if you don't have the formal knowledge of them. So the first one I covered is that when you have an equation y is equal to u plus v, your derivative becomes the y over the x is equal to the u over the x plus the v over the x. So when we also have y is equal to uv, your derivative becomes the y over the x is equal to u dv dx plus v du dx. That's also known as product rule. Then next we'll talk about chain rule, which when we have that y is a function of u and u in turn is a function of x, so that means the y dx becomes the y du times du dx. That's also known as function of a function or chain rule. Then last we'll talk about quotient rule, which states that when y is the quotient of two numbers or two functions u and v respectively, then and note that u is the denominator and u is the numerator and v is the denominator. Now then your derivative of that function becomes the y dx is equal to v du dx minus u dv dx over v squared. So basically with this we've come to a fundamental close to the first part of our differentiation classes, and then in some subsequent videos we'll be doing calculations. Thanks for watching.